بسم الله الرحمن الرحيم. نكمل. The second algorithm is the partial product algorithm. Before we getting to this strategy, we will solve an example from Unit 1. Decompose the following numbers. 536. Decompose it like this. 500, so I will write 5 and 2 zeros plus this is 3 in the tens place, so it will be 30, and this 6 in ones place, so it will be 6. Another way, this is 5 and count how many digits before it. 1 2, so I will write 5 1 2 2 zeros. I will write 3 before it is a 1 digit, so I will write 0. This 6, there is no digit before it, I will write 6. This 1, I will write 1. 1 2 3, so 1 2 3 zeros plus this 2 2 1 2, it's 2 zeros plus 7 is 70 plus 5, and so on. It's 200 plus 60 plus 4. This is the decomposing of numbers. To start with examples to show the partial products algorithm. The partial product algorithm. The first example from student book. Also, the first example is here. Solve by using the partial product algorithm. 4,731 times 4. Start making like this. 4,731 times 4. And make like what I'm doing. It's 4 times 4. 4 times 4. It will be 16. But notice that this 4 in the thousands place, so I will write 1 2 3 zeros. Another way, this 4 times to this 4. This 4 in thousands place. Before we write the multiplication result, I will write 1 2 3 zeros. Why? Because I have this 4 in the thousands place, so 1 2 3, I will write 1 2 3 zeros. And start. 4 times 4, it will be 16. It is the first line. The second line will be 4 times 7, but before we doing the multiplication product, I will write the 7. How many digits before it? 2 zeros, so I will write 1 2 and start. 4 times 7. 4 times 7, 28. 28. The third line, it's 4 times 3. Before we write the answer, it's 3 in the tens place. Before it is a 1 digit, so I will write 0. 4 times 3, it will be 4 times 3. It will be, okay, thank you, it will be 12. The fourth line, 4 times 1, it will be just 4 in the ones place, and start adding these numbers together. 0 plus 0 plus 0, 4. 0 plus 0 plus 2, it will be 2. 0 plus 8 plus 1, it will be 9. 6 plus 2, it will be 8, and drop the 1. And the answer will be 18,924. The answer will be 18,924. Another example to show it. This example, I have here 29 times 4. Start with like 29 times 4. And 4 times 2. 4 times 2. Of course, this 2 in the tens place. So I will drop 0 at first. 4 times 2, it will be 8. And 4 times 9, it will be 36. And I will write 36. So I will adding these answers together. 0 plus 6, it will be 6. 8 plus 3, it will be, thank you, it will be 11. So the answer, it will be 116. Another example. With this example, it's here. 5 times 343. I will write 343 times 5. Start with 5 times 3, 15. But the 3 in the hundreds place, I will write 2 zeros at first. And 5 times 3, 15. I will write 15. Don't forget the commas. 5 times 4. This 4 in the tens place. So I will write 0. And 5 times 4, it will be 20. So I will write 20. And at last, 5 times 3, it will be 15. 5 times 3, it will be 15. And adding these numbers together, 0 plus 0 plus 5, it will be 5. 0 plus 0 plus 1, it will be 1. 5 plus 2, it will be 7. Drop the commas. 1 plus nothing, it will be 1. And the answer will be 1715. Another example. Here he solves this this example, and he tell me to complete the missing numbers. He start with 6 times 6. He drop 3 zeros, and 6 times 6, 36. So here I will write 6 times 6, but in the thousandth place. So I will drop 1, 2, 3 zeros. Here 6 times 400. 6 times 400, it will be 0, 0. And 4 times 6, 4 times 6, it will be 424. Just like this. Again, it's 120. 6 times what? 6 times 6 times 20. Because 6 times 2, I will drop 0, and 6 times 2, it will be 12. 6 times 1, it will be 6, and adding these numbers together, 0 plus 0 plus 0 plus 6, it will be 6. 0 plus 0 plus 2, it will be 2. And 0 plus 0 plus 1, it will be 1. And it's 0 plus 4 plus 1, it will be 5. Sorry for this. And 6 plus 2, it will be 8. And drop 3, the answer will be 38,526. The third way to multiplicate the numbers, it will be the standard multiplication algorithm. The standard multiplication algorithm. Again, I use examples from the student book, page 275. The first example here, 32 times 3. It's easy to making like this. 3 times 3 or 3 times 2. In the partial algorithm, I will start from the largest place value. Here, I will start with the ones place. So 3 times 1, it will be 3 times 2, it will be 6. And 3 times 3, it will be 9. And the answer will be 96 without doing the partial algorithm. Another way, another example. 6 times 7. Start with the ones. 6 times 7, it will be 42. 42. You will write the ones and carry up the tens here. So it will be 6 times 1, it will be 6. 6 plus 4, it will be 10. And the answer is just 102. 102. Let's move on to another example here. 134 times 2. When we're doing the standard multiplication algorithm, remember, I will start from the ones. So 2 times 4, it will be 8. And 2 times 3, it will be, bravo, it will be 6. 2 times 1, excellent, it will be 2. So the answer will be 268. Another example, 758 times 3. Start with the 7? No, I'm here in the standard multiplication algorithm, so I will start from the ones. 3 times 8, it will be 24. I will write 2 and carry up 4. It's 24. Right, I will write the 4 because it's in the ones place. So I will write 4 and carry up 2. 3 times 5, it will be 15. 15 plus 2, 16? No, it's 17. Again, I will write the ones, 7, and carry up 1. 3 times 7, it will be 21. 21 plus 1, it will be 22. And don't forget the comma. Another example. Here, 1,349 times 2. Again, start with the thousands. No, I am not here in the partial algorithm. No, I am in the standard algorithm. So 2 times 9, it will be 18. 8 and carry up 1. 2 times 4, 8. 8 plus 1, thank you, it will be 9. And 2 times 3, 6. 2 times 1, it will be 2. It's easy. Another example, 2,327 times 4. 4 times 7, it will be 28. 28. So I will write 8 and carry up 2. 4 times 2, it will be 8. 8 plus 2, it will be, it will be 10. 0 and carry up 1. 4 times 3, 12. 12 plus 1, 13. I will drop 1? No, I will write 3 and carry up 1. 4 times 2, yes, it's not 7, it's 8. 8 plus 1, of course it's 9. So this is the answer. I hope you are familiar with the 3 ways of multiplication now. Another example I have here. An example, tell me you do 32 times 3 in the standard multiplication and knowing the exact answer. It's easy. 3 times 2, it will be 6, and 3 times 3, it will be 9. Now, when we use estimation by front end, this 32 become 30, and this 3 become 3. Doing this multiplication will be drop 0. 3 times 3, 9. Is this answer close to this answer. It's a little bit close, but the exact answer, we knowing it from the multiplication process by the three ways that are mentioned. It's the area way and the partial algorithm and the standard multiplication algorithm. Let's move to another part. It's a challenging example. I have here 9 times 43. I will solve this example by the three ways: by the area model, by the partial product algorithm, by the standard multiplication algorithm. Start with the area model. In the area model, we draw a rectangle, and right here I will write 9, and here I will write the example again, and here I will divide it 43. It will be 40 plus 3. So divided the rectangle. This is 40 and this is 3. 9 times 40. It will be, drop 0. 9 times 4. 9 times 4. It will be 36. And here 9 times 3. It will be 27. So adding the answers together, 360 plus 27, it will be 0 plus 7, 7, 6 plus 2, 8, and drop 3. So the answer, 387. Again, this example by the partial product algorithm. I will write 43 times 9. Start with 9 times 4, but this 4 in the tens place. So I will write 0 at the first line. 9 times 4, 36. Okay, the next line. 9 times 3, just 27. And start adding the numbers. 0 plus 7, 7. 6 plus 2, 8. And drop the 3. It's the same answer. It's the same answer here. I have the same answer. Again with the standard multiplication algorithm. And notice that I have here 43 times 9. 9 times 4? No. In the standard multiplication, I will start with the ones. In the partial multiplication, I will start with the largest place value. The largest place value and doing the zeros. So here 9 times 3, 27. 7 and carry up 2. 9 times 4, it will be 36. 36 plus 2, 38. It's the same answer. So, my lovely student, you will choose any strategy you want, by the area model, by the partial product, by the standard multiplication algorithm, and doing multiplication by one digit factor, as you want. It's an easy way. The last part of the session, it will be the distributive property. The distributive property. What is the distributive property? I have here an example. It's 78 times 4. I will write 4 and making like this times, make a bracket. In this bracket I will write the decomposing of 78 like this. This is 7 in the tens place. It will be 70 plus 8 plus 8, and start like this. 4 times 70 and 4 times 8. So 4 times 70 plus 4 times 8, and doing multiplication. 4 times 20, 7, drop 0, and 4 times 7, yeah, it will be 24. No, it will be 28. Plus 4 times 8, I think it will be 36. No, it's 32. And adding this number together, the ones with the ones. 0 plus 2, 2. The tens with the tens. 8 plus 3, 11. Am I write the 11? No, I will write 1 and carry up 1 here. 2 plus 1, 3. So the answer, it will be 312. 312. Sorry for this. The second example, I have here 1193 times 5. I will drop this 5. This is 5 and times. Make a bracket. Decompose this number. This is 1 in the ones place? No, it's in the thousands place. So 1 and making 3 zeros. Plus this one in the hundreds place. So I will write 2 zeros. Plus this is 9 in the tens place. So I will write 0. Plus this is 3. And doing like this. 5 distributed into the brackets in the 4 numbers. So it will be 5 times 1000 plus 5 times 100 plus 5 times 90 plus 5 times 3, and start the multiplication. Drop the 3 zeros here. 1, 2, 3, and 5 times 1, 5, plus drop the 2 zeros here. 0, 0, and 5 times 1, 5, plus drop the 0 here. 5 times 9, it will be 30? No. 35? No. It will be 45. Plus 5 times 3, I think 40. No, teacher. It will be 50. And start adding these numbers together. Ones with ones with ones with ones. 5, 0 plus 0 plus 0 plus 5, it will be 5. Tens with tens with tens with tens. 0 plus 0 plus 5, it will be 5. 5 plus 1, 6. Hundreds with 100 with 100, there is no 100 here. 0 plus 5 plus 4, it will be 9. And 1000, 1000, there is no 1000 here, there is no 1000 here, there is no 1000 here, so it will be 5965. 65. I hope you are doing well, and see you next time. Thank you.